Hello guys, my name is Orestes. In this short walkthrough I'm going to show you how I made the skull simulation using Cinema4D. So I got the data from Vito. Let's bring it here on the scene. We have a skull object here. We can see it's pretty small, and we can bring the wireframe, and it's pretty dense also. Let's name this high poly skull, and let's bring the floor also. So the floor is even bigger than the skull. Let's just bring it in and see how it looks like. So we can already see it's pretty heavy, even though the size does not show. We cannot even see the polygons, it's so dense. And because it's so small, we can see the camera clipping here. So first of all, let's make it bigger. I don't remember exactly the scale it should be. Let's try something like 12. And we will need to work on that subdivision in order to be able to simulate on it. So let's name this high poly floor. So the reason I want to simulate on it instead of a plane is to keep these ridges on affecting the simulation. So we can see it's based on quads. So what I'm going to do is switch over to the sculpting layout, and with the floor selected, I'm going to unsubdivide it. So Cinema will do all the work here and give us a result. And there we have it. So now we have a sculpt object floor, and the previous floor we can get rid of it. Now on the unsubdivided floor, let's go to our sculpting layers, and we can reduce the sculpting layers now. Now for the simulation, I think we don't even need any subdivisions at all. Let's go to the base level, and on the tools we have a command to create a polygon copy of this level of subdivision. So we don't need this anymore. Let's name this low poly floor. And now about the skull. The skull, we can see it's imported with triangles, and that's not going to unsubdivide it very well, but we don't need any proper topology on it anyway. So I'm just going to bring the polygon reduction deformer, and let's switch to the standard layout. You can see it's all messed up because it has a normal tag. It gives an absolute normal value to every polygon, and now the polygon indexes are changed. So let's get rid of the normal tag, we don't need it. And let's play with the values of the polygon reduction. Let's try 98% reduction. That should be a good enough base shape for simulating. So let's right click and select current state to object to make a copy of it. And let's select these two high polys and group them together on a high poly group and hide the whole group. So now we have a skull. We have a low poly floor, which we can see it's pretty rough because it doesn't have any Phong shading on it. Let's just copy this Phong tag on it and use a lower Phong value. Alright, so we can start simulating now. Let's bring this higher, around here. Let's rotate it a little bit and select both objects. Let's rename the skull to low poly. Select both objects and go to the simulation tags, and I'm going to add some rigid body tags on them. And on the floor I'm going to turn off the dynamics, so it's a collider and not a dynamic object. So we can see how it looks, and that's because of how tiny it is. This is how it solves by default. Let's go to the dynamic settings and change a few things here. Let's go to the expert tab, give a smaller collision margin, and on the scale of the simulation, let's make this something like 5. We can make a default cube and see the size difference in approximation. Alright, but the gravity is pretty strong still. Let's reduce it to something like 50. Alright, so now we're getting something. We can see it's sliding a lot, and the reason is this floor is not being interpolated with all the ridges. Let's enable the visualization in the dynamics, and we can see this subdivision is too small for the floor, and on the skull it's not proper also, even though it keeps roughly the shape of the skull. But on the floor it's almost flat. So let's go to the floor object here and change, on the collision tab, change the shape from automatic, which tries to give the lowest, the fastest and lowest subdivision kind of collision shape. Let's give it a static mesh, which is going to keep all the details of the mesh. Now you can see it's pretty slow, but a lot of this speed is because of the drawing of the visualization. Let's turn that off. Play again. Alright, so we get a more detailed simulation, and in order to even increase it even more, we can go and do the same for the skull. Now it's not a static mesh, it's a moving mesh, and it's going to keep all the detail of the skull. You can see the simulation changed. Let's enable the visualization, and now you can see the skull. It keeps everything in the teeth and all the details of our low poly model. Let's disable this. Alright, so now if the skull would fall, it would need to be probably a little higher. It's a ring after all. Alright, it takes a while to drop, so let's give it some negative frames here. We can see it doesn't solve so great, but it all depends on our settings here. First of all, we just need some initial velocity on it. It's not going to just drop vertically. So let's try to give it some velocity on screen right direction. So in the dynamics we can give it some custom velocity. We can use the object coordinates, but it's a little difficult to use. So let's try the world coordinates. On the x-axis, let's try something like 20. Alright, now we can see it's moving, but it's moving a lot. Let's try 5. Alright, cool. Let's try 7. Alright, and let's give it some angular velocity also. Let's give to all the rotations 360 and see how that looks. Alright, you can see, because it's falling a little fast, I think it's intersecting the floor and then it gets stuck. So let's try to give it some more sub-steps per frame. Let's increase this to 10 and see how it looks. Alright, now we're getting a proper solving. Let's increase the friction a little bit. So I'm selecting both tags, and on the collision tab I'm going to increase the friction to 50 just to force it to roll a little bit more. And let's play a little with the initial settings here. Alright, now we're getting something more interesting. Let's select our skull and make it a little more bouncy. Let's try 80% bounce. And let's try the initial velocity again. See if we can get a more interesting result. Alright, that was nice before. I'm playing with negative and positive values here. Alright, so we're getting something. This is not too bad. So I'm going to add a little more detail here. We can see it's a ring, but the more mass is on the bottom. So I'm going to change the center of mass just a little bit, because if I change it too much it won't be able to roll. So let's go on the dynamics tag of our skull, and on the mass tab I'm going to use a custom center. So this is object based, and we can see the Z coordinate that needs to be lower. But how much lower? Let's bring a null here, and let's bring our reset PSR command. I'm going to add this on my layout and reset the transformations of the null. Alright, and let's bring it a little lower. So maybe around here, 0.1. Let's go, but negative 0.1, right? So let's add negative 0.1 to the z-axis here, and let's get rid of the null. Let's see how our simulation looks. Wow, it fell down. Let's try again the initial velocity here, different settings. Alright, maybe this is too much rotation on this axis. Let's give it a little lower. Alright, this is not bad. Let's increase our frames here. I increased a second. See if it will finish. Oh, let's make it 140. Alright, this is not bad. So I like this, and I will export it. Let's see how it looks after we bake it. So we need to bake the simulation in case we need to reuse it, and we want to keep it exactly the same. Let's go to our Command D, go to our project settings here on the dynamics. On the cache tab, if we click bake, it will bake all the dynamics of the scene. Alright, let's go to frame 0, because this is the frame I want it from. Then we get a nice simulation here, and we want the high poly skull, right? So let's make a copy of the high poly skull and delete the polygon reduction deformer, and I'm going to constrain it on the low poly skull we just simulated. So select the high poly skull, then the low poly skull, and go to character constraints, add a PSR constraint, and I'm going to hide the low poly skull. So now we just see our final mesh doing the simulation. Basically, before I hide it, let's make sure there are no problems, it's following perfectly. And so it seems. Alright. So at this point we can export it. We can export it to a number of different formats. We can export it to Alembic or FBX. But from experience, if you export it to FBX, you might have a little more control on the curves and avoid. Let's save this, by the way. Let's go and save this. You might have a little more control on the curves in case you want to retime it later on another software, because the Alembic may have some jumps on the curves, like a rotation to go plus 360 value from one frame to the other frame. So let's bake this into keyframes first and examine it. I'm going to drag our high poly skull into the timeline and go to the functions and bake it. Make sure the bake expressions is on. I'm going to just bake it from frame 0, and we don't need to create a copy. Yeah, and as long as position and rotation are on, we can click OK. It baked it instantly, and we can see the position track here. But what I'm interested in is to take a look at the curves and make sure it's okay. So let's select our rotation curves We don't see anything suspicious from one frame to the next to jump like 360 frames. It looks fine. Position, it looks fine. Well, position we would notice anyway, but the rotation we wouldn't. So it looks okay. So now we want to export it. Let's say this again. Let's just copy this and go to a new scene, paste it by itself, and file, go and export it. So I had tried this before, so I'm going to override it. So basically you just want the animation to be exported. You can click OK. It still has the constraint tag over here, but you can get rid of it. You can actually try this one more time before you export. Alright, so let's go back to our export dialog, export FBX. And the animation is on. Let's click OK. So now it's exported. The other way to export is with Alembic. You don't even need to bake it. So for demonstration sake, I'm going to delete the tracks here. You can delete tracks easily by holding Control or Command Shift and clicking these keyframe dots, and it deletes the tracks. So now it's still constrained. You can go export Alembic, and here we have our high poly selected, so we want to export selection only. Make sure you click it, make sure you click global coordinates so you get the correct coordinates, even though this will have the correct coordinates anyway since it doesn't have any parents. Make sure you enable all the frame range and click OK. So it's going to export all the frames to Alembic. Now we have exported in two formats, and we can try them here. We can bring our Alembic file, which is working fine, and we can bring our FBX file also, which also brings the camera. We can delete it. You can deselect the two export cameras on the export dialog, and we have both. One is with keyframes, the other with not. And once again we can examine the keyframes here, make sure it looks okay, and then you pass it on to your colleague Vito, who will continue it in Fusion. So I hope you liked it, I hope you find this interesting, and see you next time.